Hello, everyone. Welcome. Very pleased that so many of you have joined us today. This is the topic on cybersecurity in the railway industry. So with Sylvain, we're going to show you a new methodology that is dedicated to railway systems. A new methodology on risk analysis. So the acronym ARAMIS is also quite telling. The name of that methodology will have a different name at the end. So ARAMIS is a name that's already on the market, so there'll be a different name coming up soon. So who are we? Serge Neviel. I'm responsible in Alstom of the entity governance and expertise on cybersecurity for products that are being sold by Alstom. So we have a dedicated team in Alstom to make sure that the railway systems are secure and resilient to cyber attacks. And I'm a member of that particular entity. And my name is Sylvain Tanguy. I'm a consultant and product manager for Airbus Protect on the subject of expertise and risk. And today we are looking at analysis of risks. We work together for 7 years now, for 6 years. And we are working on cybersecurity specifically. Airbus Protect is a branch of the entire group dedicated to cybersecurity and sustainability. So we have the partnership that has been ongoing for several years now on cyber security topics. So this methodology that we will present to you today is one of the key aspects of this partnership. In terms of methodology, why did we need to create a new methodology? So we're going to start from the needs, the requirements for Alstom. It can be extended to a certain number of other industrial systems that can be quite complex. So we can see in the audiogram here that the name of the project with specific requirements for security, it has increased. In 2020, we had 43 clients that were asking us to deliver solutions in terms of cybersecurity and resilience. And now we have 161 projects, and it's continually on the rise for all of our projects. We have in parallel a stark increase in terms of cyber attacks. All continents are affected by this. So we have a variety of methods of analyses for particular risks where there are specific aspects for each and there are certain differences. Some countries like Italy also require some bio-CRM. So there are particular requirements linked to CRM. Meanwhile, in railway systems, there is a certain set of standards called 62443, and there is a specific requirement for railway systems Europe-wide, and that's the CLCTS 5701. It's not the same as bio-CRM. There are certain strengths and certain weaknesses for each system. We will outline this in our presentation. We are witnessing growth for our teams on a number of continents, means that we also need to capitalize. We need to be certain of this. The system can have, for example, one train that's made in France and other parts of the system that are built by other countries. It's not a generalized or unified system, so there are certain specificities to take into account. There is a certain methodology for signaling, for example, and our clients don't necessarily understand that this diversity and eclectic parts for each system. It's slightly complex, and we have several methodologies that we have to make sure that they can flourish. So we need to have a return on experience in terms of what we experience. So is it possible to have them jointly working together. So to have a system for railways that can be completely compatible with CRM to satisfy our French or European clients requiring CRM, and can it also be compatible with our CLCTS 5701 and ISA IES 62443. So we reflected on this, and the key requirement here in terms of this methodology is perfect compatibility with these two standards, making sure that we can strengthen the key points of these two standards and also have a certain level of complexity that can be made automatic. On the other hand, we also look at automation systems that go beyond Excel spreadsheets. We can really have a certain level of complexity that we wouldn't have otherwise with an Excel spreadsheet. So we want to make sure that the end user can really benefit from this in order to do a risk analysis that's appropriate and compatible. So a number of constraints, 5701 and 62443, so norms that really give us some guidelines in terms of methodologies as well, describing how we have to act. And we also have the number of experiences that we need to take into account for these methodologies. When these systems, as these systems grow, there is also a certain, the complexity grows with it, and it's very difficult to manage. We can't really bring together efficiency and complexity of the systems. So BioCRM could really tackle this issue with attack scenarios and represent them with graphs, but that wasn't enough. We found that we have very large graphs for railway systems, but we find this same issue with other sectors of the industry. And there was this key question, how to address the complexity of this. So we're going to discuss this a little bit later, but these norms, notably the 62443, can provide some answers. So when we analyze a risk, we have a conception level. How can we, at the end, really make sure that it was implemented appropriately? How can we identify the different risks and the end product? So the system that's being delivered to the client. In order to do that, we needed to base ourselves on certain methodologies that were quite specific and of really bringing together a kind of symbiosis, a symbiotic relationship. It's 5713, 701 and 62443. So BioCRM is a methodology that's quite practical to use. It's well defined. You can use it from one day to the next, so to speak, because everything is quite clearly laid out and it describes exactly how it's being implemented. It's also a methodology that brings a lot in terms of the representation of scenarios. The scenarios are very practical for risk analysis in terms of prevention of attacks. So not just graphs and tables. There are a number of steps to be taken into account, and those are the advantages of the BioCRM. It has a limitation technically, but in practice it's actually not such a problem. We need to go beyond it. There is also another constraint, that is that the analysis of risk can be quite complex. On the 5701 side of the norms, competencies of CRM came from there. 62443 brings certain insights, certain concepts in terms of the structuring of the architecture in a relatively simple way. That enables us to have a risk analysis that's quite efficient and take into account a certain number of zones, different zones. Certain different things can happen. It also brings us a concept in terms of guidelines and defining the architecture of the security level target, which enables us to say that we can mitigate certain risks and we can give ourselves some particular objectives. Those are the two key points, because once we have the security level target, every dimension, for example, from 0 to 4, can help us generate or define a coherent system with systems that are really implemented at product level and a coherent system for industrial systems. Those are the two key aspects. Another key point to keep in mind for TS 5701 or IEC 62443, it really encapsulates design and concept at a conceptual level. A few weaknesses as well. For example, we don't have the notion of TACBAF. We have an architectural vision, but we cannot see certain risk mitigation and how to mitigate attacks. At the risk analysis level, on a detailed scale, it cannot give us really a very specific or precise guidelines. You can identify threats, but once we reach the detailed vision, there is no methodology that is provided with it. So that's a slight lack in the methodology. So it can be complemented. And therefore, by mixing together both methodologies, we can make use of this notion of TACBAV in different zones, and also to construct scenarios where we have this kind of symbiotic relationship, and therefore deliver something that's quite interesting. On the other hand, it does not really integrate itself that easily. So there are a few more steps to be undertaken for this. So I'd like to share with you the methodology in our system. So how did we construct this methodology? So we had to do a benchmarking, to check the systems. We had to check what was already existent on the market. We've now done a number of workshops, of working groups. People had very diverse ideas. So certain ideas on 62443 norm, and there was major concepts that arose from these workshops. So if we look at the Airbus team, they had designed a particular methodology with a cycle of rereading, and then we wanted to proofread the concept manually on a very particular case study. From there on, we could finalize it, and it gave us the methodology which Sylvain will outline for you now. Thank you, Serge. So this methodology, I'm going to outline it to you quite briefly. I'd like to outline just some of the key points in terms of innovation, since we have a limited time, but I'd be delighted to discuss it in further detail with you later. So there were 5 modules. Module 1, which consists of framing the analysis, identifying the key assets, or its composite elements. We also have a conformity level that's also very useful in the railway systems, because we often have referentials that are being imposed upon us from clients or authorities. Module 2 is focused on the types of attackers that could attack us and why, what are the probability of it happening. And module 3 shows what their itinerary is, so to speak. So we look at everything that surrounds the methodology, so we can find certain providers, but also a number of networks, for example, the client's network or of the railway system itself. We can also have access to maintenance, etc. Module 4 is focused on the technical elements of the entire structure, and it's the longest of all those different steps. So once we identify risk, how do we mitigate them? So among you, some of you may have recognized the structure in 4 workshops that we entitled module. That's the inspiration. So we started with those BioCRM bases. So we added a few more further ideas that came from the ISA IEC 62443. So we added this contextually, the fusion of the view from the attacker, the objectives that the attacker wants, together combined with those of the defender, what we call the dreaded outcome. We also have a number of operational scenarios that are being proposed, and 62443 goes even beyond this. It deconstructs the module into different zones, so we can work zone by zone, and that way we can deconstruct a complex problem into a number of much smaller problems that are practically a win-win situation for us. So we have a number of smaller problems that can help us simplify the outcomes. It helps us have a clearer view, a bigger picture, and it's also key to make sure that everything is pertinent and efficient. And we really need this global, this very broad picture, so we have it combined and we integrate it with a more detailed perspective. Module 5, the last module, has a major difference, is that we outline the measures by groups, which we call security levels. It's defined by the 60443 norm. That's one of its key strengths. Key point of Module 5 is the ability to evaluate risks as it is towards the end. All of this is compatible with 5701 and 62443, which encapsulate our key objectives. We are also very strong on those points. And Serge, now I can hand over the mic to you. Thank you. In BioCRM, we have the notion of attack itinerary. It can be quite direct in terms of operations, or via the supply chain, etc., and concepts that come from BioCRM directly. However, this is an add-on to the system, 62443. It's a very schematic structure. We define it in different zones. The attacker could enter via one zone, that is, for instance, a gateway that gives access to the network. This gateway can lead us directly to some of the data, and from there on we can alternate from one zone to the next. One zone would be one safety critical to avoid consequences that are undesirable for us. Our vision is to define these different zones and to define, by as its same token, different zones that can help us also define particular defense measures in order to take into account those attackers. So we don't want it to be overly complex. We make sure that we can zoom in, for instance, in one zone and in one particular gateway. There are different ways in which to enter the zone and different itineraries, so to speak, of the attack to see where, how they enter these systems. We can do a risk analysis that's more detailed on this perspective. We have techniques of evaluation, of assessment, in terms of the impact that are more traditional. So I've identified a certain number of attack itineraries. Another innovation for this, with regards to this methodology, is the ways in which we can measure the security levels, which are applied to each of the different zones, and it corresponds with the different levels of mitigation and of risk. So it gives us the number of measures that are corresponding with it. To each level, there is a certain level of security risk and analysis. So the security level is being measured at the same time to make sure that we do not go beyond a certain level. We have the same values, and we have other parameters taking into account the attackers. There isn't the same level of security needed depending on the type of attack. So it's completely codependent, the level of security and the level of attack. We started with a formula that's automatically can be automatically altered in terms of added values. identification of particular case studies, the identification of the particular models. In risk, one key subtopic is to define particular models. We know in advance that are connected to particular models, but we have to make sure that they do not become overly complex. So the risk analysis is linked to that particular added value, and it helps us prevent having to do too many calculations manually. Just one little add-on here. One of the advantages of this methodology is to respond to that norm 62443, which does not necessarily explain how to go from one target level to the next, to the zone that it constitutes. Via these attack itineraries, it doesn't necessarily depend on the analyst. So each component needs to be attached to that particular target level. And that way we have a kind of a more holistic approach. Via this methodology, we can also have the possibility to define and to measure the particular add-ons. So we don't have the same requirements for each level. For instance, if a system is a bit more critical, if it's a bit older, and therefore there are a certain number of constraints in terms of the implementation, and there are alternate ways to do. But this 62443 norm does not define exactly how. So we have standard measures that enable us to use a certain security level that can be used as well to make sure that we can calculate the remaining risk, the residual risk. So we have limited time now, so I'm going to outline it quite briefly, so we can focus on those zones that are being done in advance. So parametric securities on different levels, different steps. And analyzing these different stages can help us really measure the securities to make sure that they encapsulate all different levels. We can also add so-called security barriers. So this notion of barriers makes sure that we can really encapsulate all different securities in different scenarios. This is an example that's quite telling, actually. Tell us that the sum of two parts, so that the entity in its globally has more than the sum of its parts. That's quite an interesting concept of 62443, but this concept is not clearly defined. It's more based on the expertise of those involved. So we're not able to formalize that in those 4 case studies. It enables us to have a bit more objectivity to those add-on measures. So the whole point of these add-on measures is to have a high level of security. And what are the objectives of this? Well, we can make it a bit more automatically. We can make sure that it's not 100% automatic. There was always some level of human interference here. But the analyst must really observe in terms of the risk analysis. There are always particular case studies, but it can accelerate the process. It helps us to evaluate a residual risk to make sure that it's always conform with our requirements, and we can also assess what the actual level is, which level is reached by those different components, and from then on we can use the same formula to calculate the final formula without having to do an entire risk analysis, which helps us really save time, and that's quite considerable. This methodology was tested. Serge mentioned this on a pilot case. It's being implemented in our software in terms of risk analysis called FENS. We implemented to test it on a larger scale in terms of the improvements that need to be made, in terms of testing large scale, so to speak. The objective is to really make it evolve. To keep in mind this whole railway system context, I'm responsible of a EWC group, working group, that aims to have a standard future for cybersecurity in railway systems. I'm very interested in the links between the two, and therefore there is the logo of IEWC here. These future standards should be should finish by July 2025, and the idea is that the methodologies will be closely linked to those standards in order to make sure that there is compliance. And perhaps the IEC team will be able to be involved in this as well. So we'll make sure that this methodology remains compatible entirely with what we've decided on those other items of IEC 63452. Effectively, it has been validated. So we had a pilot test. We will launch it in the upcoming months. We just need to wait for the defense to be. We need to make sure that the implementation is finished and completed. We hope that the pilot will be positive, and that way we can deploy it on a larger scale. Thank you to all of those of you who've contributed to this methodology. Within Alstom, a number of you will recognize some of these names. So there are actually many more people who were involved. So we have the suspension marks there indicating that it's a very big project with a big team on a number of months, a lot of people involved. So if you have any questions, please don't hesitate to ask now. The floor is yours if you'd like to ask any questions. The definition of zones is quite important, and I was wondering whether there are certain criteria, because it's based on a technical architecture, a choice of, does it have to do with the choice of impacts, for instance, or are they grouped together? So yes, there are criteria. So we have criteria linked to the IEC 62443, some that are safety or non-safety related, or things that are interconnected non-permanently. So there are particular criteria, yes. There are a certain number of criteria. Would the Podio model actually simplify the whole process? We can actually use both. The Podio model can help us really define quite clearly the certain toolkits. Once we arrive at the railway systems level, we've defined in those working groups particular models have been defined that help us really elaborate those zones and conceive of them. You mentioned those zones earlier on, and within one zone you can have different components. Does this mean that you can have cell seed that are different from one to the next? Yes, exactly. That's the objective. We have two versions. So you can have one simple version saying that one SLT is attached to one zone and all of the components are aligned, but it can also become quite costly if that's the case. So, and not necessarily that efficient. So the idea is to actually have a different version to this one. So the first version is a simplified one, but on the other hand, you can have a different version whereby for the maximum efficient, at optimal cost, we have a more detailed view of the whole. And thanks to those attack itineraries, we can figure out which of the CLTs is most efficient. And that's something that did not exist in the 62443 norm. And actually, this follows on from the previous question. We are working on a target that's unified for over 7 vectors, and there is a particular component that is part of the component, or is each component attached to each of these different areas? So we look at the attack itineraries, and then we check which zone is attributed to it. So which zone has the most components that are attributed to it. And that way we can figure out, in terms of the risk analysis, we can figure out that there are no major risks that are linked to it. and that all of those are mitigated, and all of the toolkit surrounding this tool fence help us deploy a number of components and therefore have a more global vision overview of these different sets to make sure that the SLT of the zone is adequate. We invented this methodology knowing full well that it could be rolled out in terms of toolkits. 62443 norm is very difficult to roll out differently, so we need to have this set of systems in accordance with this particular objective. One last question: if we use these kinds of toolkits, what kind? It cannot only be from conception up to deliverables. It needs to be more global, because since systems can become vulnerable, systems evolve, we also have to change the systems. So the idea of the notion of keeping it up to date is very important as well. So the whole point of having a tool is that you can easily update a system that, or a risk analysis that has been done before. You can do it via Excel, but it's slightly more tedious. The idea of a tool is that you can assess a risk analysis system and then update it to make sure that it can be accelerated compared with the original version. It also raises the question of how to take into account these risks in advance. If we take into account the different phases of its evolution, for a train, for example, since we're talking about railway systems, we can find it from its at production level, operational level, but also in terms of maintenance. We don't have the same problems, issues raised throughout those different stages, and that can be improved with the tools. And that's the objective. We spoke about SLA. The objective is to make sure that we can really update the risk analysis throughout the life cycle of this risk analysis. That's part of these requirements for the methodology we have currently. We want to make sure that the risk analysis can be updated, can be modified throughout its existence. Hello, Nicolas Valence. I was wondering whether you would like to set out this methodology in an open way. Excellent question. We are discussing this at the moment. For now, it is private, but there are also discussions ongoing about opening it up, so that's not excluded. In inverted commas, there are no conditions, but we need to have a forum that's dedicated to the maintenance of this methodology. And there's also the tooling aspect. All of our legal structures need to be taken into account, also in line with the objectives of Alstom and Airbus. But that seems to be a good idea, in my opinion. There are a number of people from the cyber campus who could also get involved. Hello. What I'd like to know is that once you've implemented this in Alstom, what was the impact of this solution that was implemented in terms of the methodologies and the existing methodologies? Whom do you present this to? What's the conclusion of this implementation of this new solution fence and methodology? It's a bit early for us to answer this now, but we would be pleased to present that next year in more detail, hoping that it could be successful. The idea is for it to really serve the needs of Alstom. If it can serve the needs of those operating managers from the railway sector, we would be very pleased, and we can see that it's all based on the 62443 norm. There are certain aspects of it that are linked to 5701, but it could also be useful for the industrial sector at large. Thank you. Thank you for the presentation. I'm in IT. I'm not in the railway sector specifically, but I think that I can always learn from the industrial sector. Can you use those methodologies in terms of the risk analysis evaluation? And can you also define a bit further those zones that you mentioned? Because in IT, we have a certain number of steps to be reached before we can reach those zones. And can this methodology be applied in IT, for example, software editing, which is the case today? Excellent question. Well, a short answer would be yes. But this methodology is conceived for industrial systems, and it adds complexity that's not really required in IT. But as you mentioned, there are different stages to each attack, and this deconstruction into zones can also be found in IT. So what we do is that we retrieve the concepts and we integrate them into BioCRM 50701 and 62443, and within BioCRM framework, we can add some elements that are not contradicting the other ones. These are good ideas for us to extend this methodology. It's something that we're working on currently at Airbus Protect, and we're considering adding it to our software rents. So the best example would be, for instance, in terms of risk analysis in IT, when you have operational systems, you have scenarios that are quite complex. The idea would be to also deconstruct in that sector into specific boxes, so to speak, a kind of drawer system that can help us really identify and deconstruct certain elements of risk analysis so that we can work on that level of abstraction and then have a more detailed view within each drawer of this methodology so that we can really succeed in that particular stage.
Then I'm interested in this method, like our colleague just said a bit earlier, to make it public, because right now we are French editor of softwares, we are French host, and today the strategy established by the leaders is to try to have all the products, all the providers, all the ideas, all the French one we can have within the companies regarding the geopolitical context.
Je crois qu'on a encore un peu de temps, on a dépassé.
En théorie, on a dépassé, mais personne.
I guess we still have a few time for questions. No, yes, we're a bit over of the time. Thank you very much for your attention.